main purpose of my coming here is to congratulate all the countrymen for what we have done. So it is there. So this is a news item which has come in the newspaper, what our country is doing to meet Bharat Stage VI norm. So the first thing is the India to switch towards cleanest petrol diesel from April 1, 2020. Almost all refineries were producing Bharat 6 Euro grade fuel by the end of 2019. And it's a very good news for all of us. The reason is that within a period of 3 years, our country has been able to come up to the expectations of the world. And many of the countries, they have taken much more time. And since there are many reasons that our country can do much better in many aspects, but it is only our negativity which comes into play. So this is the news. The Sanjeev Singh, he is the chairman of IOC. So he has said and this IOC, as you all know, it controls about half of the this oil production in our country. So all the refineries began producing ultra low sulfur Bharat Stage 6, and which is equivalent to European 6th grade fuel by the end of 2019. And if we just look into the emission standards, so India adopted Euro 3 equivalent to Bharat Stage 3 fuel with sulfur content of 350 ppm. So that was in 2010. And within a period of 10 years, we have brought the level to 10 ppm. So at the moment for Bharat Stage 4, we are getting 50 ppm sulfur content in diesel. And by the next 1.5 months, so we would be getting Bharat Stage 6 diesel as well as petrol, and the ppm level is 10. Now this is, if you see the change, it has come from 350 ppm to 10 ppm. So that's a drastic reduction of sulfur content in the fuel. So, and this was not possible without the efforts of the government. And one thing which our country has done, it has taken a very strategic decision to forego the Bharat Stage 5 norm and straightaway jump from 4 to 6. So otherwise, it could have taken much more time than it has taken now. So we have achieved the goal, and this with this 10 ppm, this fuel will be equivalent to the CNG. So at the moment, as we all know, that the CNG fuel is much more cleaner than the other fuels, the gasoline or diesel which is available to us. So that is the first thing. And another important aspect is the sulfur reduction will reduce particulate matter emissions even in use older generation diesel vehicles. Now, if you put a clean fuel into an older generation vehicle which is not compliant, and as you all know, from this year only 2020, we would be getting BS6 compliant vehicles, and most of the vehicles which we apply on roads, they will not be BS6 compliant, but most of those will be BS4 compliant. So if you put in this quality of fuel into that, so it will also reduce the emissions from the ongoing in-use vehicles which are not Bharat Stage 6 compliant. The new fuel will result in a reduction in NOx vehicles by 25% in petrol cars and 70% in diesel cars. So, if we see the fuel upgradation policy, so our country started adopting it from 1990 onwards. So, and in 2000, our country started using the unleaded gasoline fuel. Now, the Bharat Stage 2000, which is equivalent to Euro 1 or BS1, so they were first introduced in April 2000, and it is within 20 years that we have come to the Bharat Stage 6 norms. So during this period, the benzene limits have been reduced to 5%, from 5% to 1%, and lead content in gasoline has also been reduced in phases. And at the same time, the research octane number, as you know, the octane number is giving the performance of the increase in the performance. So it has also been gradually increased from 88 to 91. So basically, more the octane number, more is the performance of the vehicle. So this is all about about this news. Now, the another thing which I have come and I want to share is, so I have already written a chapter on this aspect, which is available in this book. So if I'll just give you this is chapter 6, which describes everything what I want to share with you. So today's our discussion would be there on this chapter, which is already published, and this is the copy of the book. And the outline of today's interaction is, first we'll talk about the emissions from diesel vehicles, and which is the main cause of concern for the pollution related deaths worldwide, its impact, and the skipping of this the policy of government, that how they skipped Bharat Stage 5 norm and straight away they moved on to Bharat Stage 6 norms, because of which there is a reduction of particulate matter and NOx by 80 or and 50%. Then we'll also talk about the exhaust control technologies to reduce NOx and PM levels, the existing strategies to combat this PM and NOx level, which are not sufficient in nature, and that is why we have to see how can we be able to achieve this. The next, the interaction would provide an insight and suggest the ways and means to achieve Bharat Stage 6 emission standards by the Government of India. So in the meantime, it will be better if we can interact, if some of you are already aware of this. So I'll start with why my today's interaction is focusing on diesel engine. So as I know, everybody understands this diesel engine, SI engine. So everybody is conversant. Okay. Now, if we compare diesel engine with petrol engine, the diesel engine is more efficient than petrol engine. Now, the reason, now if you see theoretically, for the same compression ratio, the spark ignition engine has a higher efficiency, fuel efficiency, but in diesel engine, there is a limited knock, whereas we experience knock in case of SI engine. And the diesel engine can operate at a higher compression ratio, and because of that reason, it is more efficient. And in SI engines, there is a throttling loss, whereas in case of diesel engine, it does not go through the throttling process. straightway fuel is injected into the combustion chamber in the presence of air. Now, another thing is the diesel engine works at a higher value of gamma, that is specific heat. And because we are not interfering with the quality of fuel, straightaway diesel is injected, so gamma value is high. Whereas in case of SI engine, we mix air and fuel, and the resultant gamma value decreases from 1.4. So for air, it is 1.4 maximum. So that way, the two things, one is, I would always say the compression ratio is a parameter of engine design, whereas gamma is a parameter of fuel. So we have one an engine, another is a fuel. Both of them combine together to give us the mechanical output. So, and both of them has to be raised to that standard. So the problem was that during the initial years, there was a lot of tussle between the oil companies and the engine companies. The oil companies would always say that we have the best quality of fuel, and the engine companies would say that we have the best quality of engine. But none of them were taking responsibility of coming up to the standard. But now both the engine compliance has also been raised to the Bharat Stage VI norms, as well as the fuel standard, which is to be put inside the combustion chamber, that quality of fuel has also been raised. And that is why we are getting the resultant improvement. Now, another analogy which I want to give it to you is how we should see towards the emission standards. The analogy is, if we see the limits of emission standards for various pollutants, say for example CO, HC and NOx, on the x-axis and y-axis to the size of a postcard in the beginning, and today the limits have been reduced to the size of a postage stamp. Do you understand what I mean to say? So that is the reduction. So if I compare, this is the limits, and it has come to this corner only. And that is why, and this limit standard, which has been drastically reduced, could not be achieved without the total involvement of all the parameters in an engine and fuel. So the another example of diesel engine quality is that we can operate it at low RPM. So whereas the SA engine has to operate at slightly more RPM than a diesel engine, turbocharging can be done in diesel engine, whereas we do supercharging in case of SI engine. So at the moment, if we see the large diesel engines, they can give efficiency up to 55%. So whereas the ideal limit is around 98%. So that means still a lot of scope is left for improvement to move towards the ideal efficiency. So that means key work will keep on going. So these are some of the characteristics of the comparison between a diesel engine and a spark ignition engine. So it has got a better fuel economy, and we can operate diesel engine in lean condition. Now, all those who may not be knowing what is a lean condition means, more air than fuel. So, as far as the hydrocarbon fuels are concerned, the ratio between air and fuel is 14.7 is to 1. Or maybe you can say roughly it is 15 is to 1. So that means you need 15 times more air than the supply of equivalent fuel. So say for example, your vehicle has to consume 1 liter of fuel, so it will need 15 liter of air for stoichiometric combustion. But for to uh, power this engine in lean condition, we have to supply more air. So this diesel engine has a capacity or capability to work under lean conditions. Then higher compression ratio we have already talked about. Turbocharging we have already talked about. So the only disadvantage of diesel engine as compared to SI engine is the problem with the emission. So as far as the performance is concerned, it is giving better performance, and emission is worse than the SI engine. So the first thing is NOx. It produces more NOx as well as more particulate matter. Now, these are some of the disadvantages associated with the diesel engine. The first thing is it has got cold starting trouble. So everybody knows this. And all those, when we were students of BTech, we used to find the truck drivers or bus drivers on cold winter seasons that they would heat the fuel tank while parking, so that the it is because at that time the efficient glow plugs were not there. The heater into the combustion chambers, they were not of that standard which we find today. So that is the cold starting problem, so which is very much there in our country in the month of November, December, January, or to the places of higher altitude. And that too, you can see the and most of the time the vehicles, the military vehicles, they were facing this kind of problem under high altitude. Another, the noise associated with diesel vehicles. Now, before, I would say 10 years, if somebody starts a diesel vehicle, immediately you would be able to know that the diesel vehicle has started. So it was audible from a great distance. Whereas the vehicles which are being manufactured today, you would not be able to make out from the audible noise whether it's a diesel vehicle or a spark ignition vehicle or a petrol engine. So you, all of you may agree with me on this aspect. So nowadays it is very difficult to distinguish through the noise or the sound level whether you are sitting or you are riding a diesel vehicle or a petrol vehicle. So another is the slower combustion. The another aspect is lower power to weight ratio. That means the total weight of the vehicle which is being fitted with diesel engine is more than the resultant SI engine. And there are too many components in diesel engine as compared to SI engine. And the much more complicated is your fuel injection system, so which is the heart of a diesel engine. And as discussed earlier, so the NOx and particulate matter. So this is the market penetration. The diesel driving fuel economy, this is 30% better than SI engine. So this comes 5% from the fuel energy volume, 15% that we have been able to eliminate the throttling loss associated with the SI engine, and 10% from the thermodynamics, that is friction, heat transfer, higher compression ratio, and higher specific heat ratio. So when we see heavy duty vehicles, you would find the application of diesel engine. You would seldom or very rarely find a very heavy duty vehicle fitted with an SI engine. In the military application, where a large weight is associated either to carry or to transport the troops, the diesel engine is there. So it's a significant market all over the world. When you see the last small passenger car market fraction in US and Japan. So in these countries, there is, in the passenger car segment, the diesel engines are very less. And as per my knowledge, many of the countries, of the developed countries, they do not have passenger car running on diesel. So they are mostly run on petrol. Now, as the topic of the day, I have focused on diesel engine. Why? There are some aspects whereby, without putting in much resources or money, we can resolve the issue of emission. The first thing is, for a country like ours, we should not have allowed diesel engine vehicles to be used in passenger cars. So that is the biggest tragedy of our country. If we have a petrol engine driven vehicle, the problem associated with this is very less and it gives a very clean emission. But then why the manufacturers have gone in for this? So now I'll come to that during the chapter I have written. This is basically the content of the chapter. So the word wide scenario of emission norms. So let me also switch over to side by side. Now this is the chapter which I have written along with my PhD students, Dr. Rajan Kumar and Dr. Gurkamal Nayan Singh. So last year it was published in this book which I have shared with you. Now I'll come to, first of all, the reason behind the diesel engine. Now, if we read, India, as we all know, is an agrarian country. That means mostly more than 70% we depend on agriculture. And because of that reason, subsidy is being provided to the diesel, because most of the implements which are required in the agriculture sector, they come under heavy duty vehicle, heavy duty engines, and diesel engine is there. So that subsidy is provided. And because of that subsidy, the cost today, if you see the visit, so there is almost 10 to 15 rupees differential between the cost of petrol and the cost of diesel. And the subsidy was provided to for the agriculture. But the engine manufacturing companies, the automobile companies, had made use of that, and they have come up with smaller engines and put those passenger car segment into diesel. So, because of that reason, the passenger car segments are here in our country. Whereas, if you visit any other country outside, you would find the price differential is very, very minimum, not to the tune of even 1 or 2 rupees. Because when you go for the oil refineries, crude oil processing, so it is, you get all the ingredients, you will get some amount of petrol, some amount of diesel. So cost associated similarly, the production of petrol as well as diesel. So subsidy is being given to diesel and the cost is claimed from the petrol vehicles. So this is luring the automotive manufacturers as well as the customer. So as a customer, I will always go for a cheaper fuel. And as we have read earlier during my interaction, so diesel vehicles are more efficient. So then why people will not switch over? So as I told you, without investing, if instead of, or maybe simultaneously, if we can get rid of this, if the country decide be okay, no more vehicles in passenger segment cars on diesel, our problem will get reduced more than 70-80%. So we will have vehicles which are working on Bharat Stage VI standards on petrol, and as such, petrol-driven vehicles produce minimal amount of emission, and which is the case with the other countries. Another is that cold starting trouble. So we would not have any cold starting trouble also. But we can only discuss here, and we are not there to enforce, but only through these interaction, I think I can make aware people about this. So that is why I have written during the introduction about this. Now, the worldwide scenario of emission norms. Now, G20 nations account for 90% of worldwide vehicle sales, and 17 out of the 20 nations are obeying the European regulatory pathway to control the vehicle emissions. Now, if you say the Europe has adopted the emission standard as early as 1970, so that means it is almost 50 years, whereas we started adopting this from the year 2000 onwards. So, and over a period of time, it has come from Euro 1 or Bharat Stage 1 to Bharat Stage 6. So, let me skip the history of European standards. And at the end, I'll give you this PDF and you can read at your places also. So, let us see the scenario which is prevailing in our country. Now, implementation of emission standards in our country. The first stage of emission norms implemented in 1991 for petrol engine and in 1992 for diesel engine. In 2000, India first adopted Bharat Stage 1, and these were introduced in both the commercial vehicles as well as the passenger vehicles. Now, I will keep on referring to BS standard or European, these are almost equivalent standards. So there is not much difference in both these things. So in 2003, the auto fuel policy recommended the roadmap for fuel standard emissions. And from April 2010, Bharat Stage IV emission norms were executed in 13 major cities, and later on they were expanded to many other by 2014. And the target, and this is one of the, I would say, our country's pioneer work in sticking to the scheduled event. So otherwise, in many of the works which we do not stick to the schedule. We are always behind the schedule. So this is first time for this work our country is marching towards this as per the schedule, or I would say before the schedule. So already in many of the places it has already, the Bharat Stage VI compliant fuel has already started penetrating into the market. So since India started a formal emission standard in 1991, a gap in the execution of Bharat stage emission norms is compared. We can notice this gap, but this gap has assisted in the technologies to mature, which helped the Indian auto sector to achieve the emission norms at a reasonable cost for the Indian customer. Now, by switching over to emission standard by 20 years later, I think we have gained that we have learned from the countries which we have already started adopting this norm. So the changes which were expected both on the refinery sector, so as well as on the engine sector, so that experience we have taken from them. So otherwise, a huge amount of resources have to be spent our own country in order to meet this. So we started late, but we made up to the mark. So throughout the world, everybody is now Bharat stage or Euro 6 club compliant. So I think in a way we are gainer. So that is what I have written here. Now you are all aware about OBD, that is onboard diagnostic device. Now today the vehicle which is being manufactured or the engine which is there is not a mechanical component. More than 40% is computer controlled. There is an ECU fitted on board the vehicle, and all the mechanical adjustments have been eliminated through the use of computers, sensors, and actuators. And the job is being done, and the name of the device is OBD, onboard diagnostics. Now, there is a series of this thing. There is OBD1, which came into effect 1991. So you all must be aware about the CARB, that is California Air Resources Board. So California, which is a state in US, was the first to implement the emission norms as early as 1964 or 5. So how it came, how this board became, that one day what they experienced, that all of the sky is totally covered with dark clouds. So they investigated the problem, and initially people thought that this fog has come, or this smog has come from the chimneys of power plants. But later on, they researched and they found out the 65% contribution to the emission was from the automotive transport sector and only 30 to 35 from the industry sector. And they immediately formed a board. And from there, they started fitting vehicles with an OBD device. And the OBD device at that time known as OBD1. So it was nothing but to monitor the emission control components, whether the emission control components are functioning properly or not. So before that, there was no other mechanism to check the emission control device. But today, then we have this OBD2, which has got, so it is fitted onto the vehicle since 1994, 95 or 96, and all 1997 and newer diesel passenger vehicles and trucks were required to meet OBD2 requirements. Now, the first we had OBD1 was the emission. Now, in OBD2, along with the emission, a user-friendly system was fitted on, and it was required to give a signal for its malfunctioning. Now, most of us are driving vehicles nowadays, and when you start the engine, you see onto the dashboard there is a check sign which comes, which glows. So at that time, this is similar to what a computer does when you initially press the start. It boots, and by booting, we understand it checks all the components and software and hardware be okay. Now I'm ready to use. So similarly, in vehicle which are being fitted nowadays, they first check everything, and they gives you a thumbs up sign, be okay, everything is okay, you go ahead. So otherwise, that sign will not go off. So that means if something is wrong with the engine system. And today, earlier you would take it to the mechanic and he would start doing something there. Nowadays, all the workshops, all the mechanics, they have scanner. So it's a software which they carry into their laptop. There is a port under the dashboard. You put in your dashboard, this lead into that, and you get all the signal and data in the form of software, and it will tell you, okay, this is the code and this is the component which needs replacement or which is malfunctioning. So they either replace it, because today I'll say most of the time we have come to the age where replacement is done, repair is not there. So the mechanical component, I would always prefer, we had the choice, and a good mechanic is always the one who could repair, not replace. But today, whether it is your computers, whether it is your mobile, whether it is your vehicle, anything, so the moment it gives a malfunctioning, the technician would come and say, sir, this component or this motherboard or this needs to be replaced. That's all. Now, for a country like us, I think replacement should not be there. I always consider this as wastage of resources. And we have sufficient manpower available. So this was for the countries where the labor cost is high and the manpower is not available. And if we go for replacement kind of thing, so our manpower will remain idle. So the one way to use the manpower available in our country to repair the replaced components, whether it is computers, whether it is mobiles, or whether it is automobiles. So that is one of the losses associated with the digital revolution, the electrical transfer, which has overcome the mechanical components. So I think the role of OBD is clear now. Ah. And nowadays, we have progressed into, you would say, the OBD 2 and OBD 3. The OBD 3 or 2.5 or the higher version, the hierarchy as we progressing, is a one step ahead. That earlier you need to bring in your vehicle to the service station, and from the OBD you put a scanning device and it gives you the information regarding the malfunctioning. The OBD3 compliant vehicle would have the facility to display on board the malfunction. That means that the scanner is already installed into this. Now, you would appreciate initially we had printers and we had scanners. And today, if you see, it's a 3-in-1 device. We have printer, scanner, or maybe the photocopier fitted onto a single unit. So that means the evolution of OBD is to combine first to diagnose or detect, then to give us an information which component is malfunctioning, and third to give us a reminder on board, yes, this is what is happening. And this is the same case is true with your mobiles and your laptops, that they gives us an advance warning. Okay, memory is full. You delete some data. Okay, this particular is software or this particular file is not working. So similar is the case, and I think so. The brief period I sat with Dr. Bennett, he also said something about the hacking. I think he was talking about hacking. So another disadvantage with these electronically controlled devices is the problem of hacking. And for that matter, the security of such a system is of great importance to us. So the next revolution, I think, which would come or which is already there, or next biggest problem all over the world, like one of the problems we already faced was Y2K problem. So you are already aware about this Y2K problem? So when we switched over from 1999 to 2000. So similarly, another problem that we have mobiles, everybody is carrying, we have laptops, we have electronic fitted gadgets like automotives, refrigerators, ACs, everything, air conditioners, they are all electronic controlled, Wi-Fi controlled, Wi-Fi enabled, even your the door lock system. So the hacking, we have to safeguard ourselves. So a great amount of work is required for the safety. So many times we heard ATMs also. So ATM fraud again. So it is similar to here. So that I think will be resolved by OBD3 or OBD4, the subsequent devices which will come. So they will have these features of, and one such vehicles I think is already in the market also. So it has internet compatibility. So everything, you can put a guard also. So somebody rides that vehicle, so it gives you information onto your laptop. So it is connected to your laptop also. Now the technology upgradation from conforming to Bharat Stage 4 and Bharat Stage 6. The advantage associated, we have already talked, that it gives us limited amount of emission as compared to the previous vehicles. But this is available to us at a cost. Each vehicle which is Bharat Stage 6 compliant would cost at least more than 10, 15, 20% of the cost of the vehicle. So that cost everybody has to bear because it is fitted with many number of components, which adds number one, cost of the vehicle, number two, the weight of the vehicle. If you add more devices onto the vehicle, so power to weight ratio will decrease. And because of those more number of components, more number of sensors, more number of actuators, and why it took 3 years, 4 years, 5 years, 6 years from moving from Bharat Stage 4 to 6 is that you need to upgrade the software. Now, everything today, whether it is fuel injection, whether it is the performance of the vehicle, fuel economy, your OBD devices, they all are software driven. So, huge amount of time, data management was involved in preparing the revised upgraded software. So that is why it took so many years. The only thing is, even though we are spending as a consumer 15-20% extra cost, but we hope to save many lives. So many lives are lost because of inhaling the harmful emission present in the environment due to the passenger car segment. So that is the relief to us. Okay, let us spend something more, but somebody should not die because of this. So that is what we have written. This cost would be recompensed by the drop in decreased diseases due to air pollution, which are severe threat to human healthiness in India. Now, there is a famous saying, GIGO. GIGO in computer system known as garbage in, garbage out. That means if you feed wrong data to the computer, it will give you wrong answer. So that is known as GIGO. Now, similarly, if we fill in our vehicles with poor quality fuel, we will get poor performance and poor emission. That means more emission, more pollutants. So the fuel quality has to be upgraded along with upgrading the engine or the passenger vehicles, automobiles. So today, and that is why so much amount has been spent to increase. So the quality of fuel affects the quantity and type of exhaust emission from the engine. So it is the quantity as well as the quality which is being affected with the fuel. It directly and indirectly affects the quality of air and the amount of greenhouse gas in the environment. Improving fuel standard would facilitate vehicles and their emission control system to work effectively and assist in the adoption of advanced engine and exhaust emission control technologies. Now, one aspect we have seen here is that we have to improve the quality of fuel. Another is, if we have fitted the emission control strategy devices and we feed them poor quality fuel, they will start give malfunction. So a Bharat Stage 6 compliant vehicle, if it is fed with Bharat Stage 1, 2, 3 or 4 quality fuel, the emission control system would fail. So please, so that is why our country or the oil companies cannot sell two qualities of fuel. Be ठीक है, Bharat Stage is also being sold. At the same time, Bharat Stage 6 is being sold. No. So in a unleaded fuel vehicle, if you put in leaded fuel, so don't get carried away by the word unleaded. Unleaded still has got some amount of lead, but the ppm level is very low. So the safety of the emission control devices also depend, their functioning also depends upon the quality of fuel. Okay? Yeah. So we need to be aware about this. During combustion, sulfur in diesel fuel is converted into PM emissions via sulfuric acid and sulfur dioxide emissions that led to subordinate particular development in the atmosphere. These chemicals can also cause acid rain. So sulfur also obstructs the proper working of after treatment system, designed to low down the tailpipe emissions and corrode engine types. So that is why it has been reduced from 300 ppm to 50 ppm to 10 ppm. So 10 ppm is nothing but almost nil. So whatever the vehicles will come, so that will have least amount of. So this is the comparison of Bharat Stage 6 and Bharat Stage 4 fuel quality. Now, the combustion, that is the improved NOx advanced EDR system. Now, in Bharat Stage 6, you will have OBD 2 or higher version. And we have after treatment devices like SCR, DOC, and DPF, for which I'll talk with you in detail after the break.